In the last lecture, we have discussed about stress acting on a plane. We will see a simple example to demonstrate how to find out stress acting on a plane by knowing the stress tensor acting at a point. So, how do we do this? So, we will refer to one example problem. Given the stress tensor acting at a point, we are asked to find out what is the traction vector, because without knowing traction vector, it is difficult to find the stress acting on a plane. So, first thing is to find out traction vector and then stress acting on a plane whose normal makes equal inclination with coordinate axis. So, now this particular sentence we need to understand carefully. We are asked to find out stress acting on a plane. Now, what is stress acting on a plane? Stress acting on a plane is about the normal and shear component of the traction vector. So, that is what we have to find out. But for finding out, we need to know the normal vector. Now, what is the normal vector? So, it is told that it is a plane whose normal makes equal inclination with coordinate axis. We have learned this in the lecture. So, what is meant by normal making equal inclination? It is similar to that of a space diagonal. A space diagonal makes equal inclination with the axis. So, here we have been given with a stress tensor with its components. So, sigma is given. So, normal making equal inclination with coordinate axis, it is same as the space diagonal. Now, what is that? It is equal inclination. So, we know that the normal vector n is equal to 1 by root 3, 1 by root 3, 1 by root 3. This also we have discussed in the lecture. So, how do you find the traction vector? So, traction vector T is equal to sigma transpose into n. So, that will give you traction vector. So, traction vector T is equal to Tx, Ty, Tz, which is equal to the stress tensor into the normal vector. So, do the matrix multiplication, one will get Tx, Ty, Tz is equal to minus 1 by root 3 minus 1 by root 3 minus 9 by root 3. For example, all are 1 by root 3. So, it is 10 plus 4 14 minus 15. So, that is minus 1. Similarly, you get all other components. So, the traction vector is now known. Now, we need to find out what is the normal stress. So, how do we get that? The stress acting on a plane means normal and shear components of traction vector. So, first we will see how to get sigma normal, that is nothing but the transpose of traction vector multiplied by the normal vector. So, that is what is done here, the traction vector T and the normal vector n. So, you do this simple matrix multiplication, we will get minus 11 by 3. So, that is nothing but minus 1 minus 2 minus 9 minus 11 by 3. So, the normal stress or the normal component of traction vector is now known. Now, what is left with? We are left with the shear component. So, how do we do that? We know now what is the traction vector, we know what is the magnitude of sigma normal. So, one can always find out the magnitude of shear component, so which is given by tau s equal to root of t square minus sigma normal square, where t square is the magnitude of the traction vector and t square, you square this term. So, you will get tau s equal to 83 by 3 minus sigma normal square, that is 121 by 9. So, that will give you 128 by root of 128 by 9. So, that is about the normal stress and the shear stress component which has been asked. So, what we have done? We have done the determination of traction vector. Knowing traction vector, one has obtained the stresses acting on the plane.